Okay, we'll begin graphing logarithmic functions by just a reminder of graphing exponential functions. And remember, if we were given the function f of x equals negative a times b to the x minus h power plus k, we could describe how each value affects the graph of f of x. Remember that a gives us our vertical stretch or compression. You can also call it the vertical shrink. The h value tells us if the graph is shifted left or right. The value for b represents the growth or the decay. Remember, if it was greater than 1, it represented growth, and less than 1, it represented decay. And the k value represented any shift or translation up or down. And we also knew something about k, that k represented where y is equal to k, that represents our asymptote. And remember, if the a, or in this case the a is negative, then that means it's reflected over the x-axis. All right. When we graphed exponential functions, we created a table of values and plotted the points and then graphed the functions. In order to identify the asymptote, which value above would we look at? We just talked about that. The value right here for k represents a horizontal asymptote, and that would be where y is equal to k. And the domain, if you remember, of all exponential functions was negative infinity is less than x is less than infinity. That could also be written as negative infinity to infinity. Now let's look at what we do for graphing logarithmic functions. And there's a separate type of process that we'll be using for exponential functions, and you'll want to put this in your foldable. Maybe the steps into doing so. All right, suppose we've given the function y equals log base 2 of x. We need to go through the following steps to graph. First, we will rewrite the function as an exponential function. And remember, that would be base 2 to the y power is equal to x. And now what we're going to do is we're going to switch the x and y to find the inverse of the function so that we have it in the form of y equals. So the inverse of the function is equal to 2 to the x power. I changed my x and y, and I wrote that it was indicated that it was the inverse. Then what I'll do is I can plug that into y equals in my calculator and create a table of values, or I can just choose some values for x and solve for y. So I'm going to choose 0, 1, 2, 3, and negative 1. When I plug that in, I get 1, 2, 4, 2 cubed is 8, and 2 to the negative 1 power is 1/2. And I can go ahead and graph that function. Now what I've done is I've already graphed our y equals x line. I've graphed our asymptote for this one where where k was 0, so that means y equals 0 is the horizontal asymptote for the function. And then I'm going to plot my points. So I'll plot 0, 1. I have 1, 2, 2, 4, 3, 8, and then just to see what's happening towards that asymptote, negative 1, 1/2. And there is that exponential function. But remember, this is actually the inverse of the function I want.